So the robots are coming. The robots are coming. You've probably heard this a million times before, but I'm about to tell you it's real. And the wheels have already been set in motion with America on the cusp of a transformation of its manufacturing sector like never before. I've got Brian Wong with me. He's back to discuss a really interesting report that seems to have largely gone unnoticed. This is Foxconn, the canary in the coal mine for the robotic factory manufacturing revolution in America, is it? This is an exclusive Reuters story where NVIDIA and Foxconn are apparently in talks to deploy humanoid bots at the Houston AI server making plant. This is big.
Yes. Foxconn has talked about automation with robots actually for, I think, nearly 10 years. They had plans to, get 500,000 robots in, but they have not been able to do it. I think they got a few tens of thousands of robots deployed, but they weren't able to succeed to replace a lot of their workers. They have about 200,000-ish employees working in their factories. So this is a long-term goal that they wanted to increase productivity by going to robotics, beyond just the more industrial arm type robot type things that have existed for a while, but more of the more versatile.
Right?
Yeah, right.
Yeah.
And then Amazon has also been there, where they have 1 million, mostly pallet bot type things, where they have rolling around bots that move the shelves to the workers and increase the productivity of people moving things around. But both of those companies are testing humanoid bots in a major way, and NVIDIA works with about 20 some or more humanoid bot companies that are working to get to this goal of humanoid robotics.
With the Isaac model, but they've also got the Omniverse and the digital twins for factories. And we've been looking a lot at all of that, because this is really a fascinating play, because NVIDIA seems to be right at the center of innovation, and then all these little connections go out across the manufacturing sector. All right, so before we get into any deeper into the technology, let's look for a sec at the geopolitics of it all and the Trump administration's policy on not only bringing American manufacturing back home, but also kickstarting an American manufacturing revolution with AI and robotics and AI factories. Let's listen to U.S. Commerce Secretary Howard Lutnick and what he says here in this soundbite from April.
Where we can't get antibiotics and we have to call another country to make a missile or to make a plane. I mean, these are obvious things. We need to have domestic production. We need to employ Americans. And I think that is the model that Donald Trump is seizing on. We need to employ Americans for the good of the United States of America. Factories are coming back. And here's the key. Factories now can use robotics. And so American workers can be much more efficient with robotics. You're going to see the greatest surge in training for what we call tradecraft, teaching people how to be robotics mechanics, engineers and electricians for high-tech factories. And you're going to see the greatest resurgence of factory building and factory production in America. This is our time.
This is our time. Do you think this was just a big brand umbrella idea that brought geopolitics and policy together, and then they said, okay, let's just leave it to the technologists to take it forward and implement? Or was this signposting, the tsunami of AI and robotics and AI factories or robotic factories that we seem to be on the cusp of?
I think that if you were to do it the traditional way, where you would need millions of workers trained to do it, it'd be a tough and slow process, because we don't have, you need to have people with many years of experience to do these complex tasks. So you need to have a lot of AI and robotics in order to have this happen in any kind of a timely way. Because if you don't have the labor force, even trying to bring them in and stuff like that is a difficult thing to do. But clearly they want to have that happen.
Especially in this political environment.
Right. And to move the factories in, and then to bring some other workers in from outside, and then to have them work within the United States. So I think clearly that is the goal they have, and they need to leverage AI and robotics so that it can happen faster. By the way, one correction: previously I said 200,000 employees for Foxconn. I think they have 700,000 employees, so far
Okay.
more.
Right, far more, far more. Okay, so now Jensen from NVIDIA's CEO has had some really interesting insights a few weeks back about why AI-enabled humanoid bots are so disruptive and transformative. And let's just listen in for a bit to what he says here.
The world has a severe shortage of labor. And the reason why humanoid robotics is so important is because it is the only form of robot that can be deployed almost anywhere brownfield. It doesn't have to be greenfield. It could fit into the world we created. It could do the tasks that we made for ourselves. We engineered the world for ourselves, and now we could create a robot that fit into that world to help us. Now, the amazing thing about humanoid robotics is not just the fact that if it worked, it could be quite versatile. It is likely the only robot that is likely to work. And the reason for that is because technology needs scale. Most of the robotic systems we've had so far are too low volume. And those low volume systems will never achieve the technology scale to get the flywheel going far enough, fast enough, so that we're willing to dedicate enough technology into it to make it better. But humanoid robot, it is likely to be the next multi-trillion-dollar industry. And the technology innovation is incredibly fast. And the consumption of computing and data centers, enormous.
Yeah, so when we look at Foxconn, so this is for the server making plant, but Foxconn also makes Apple phones, right? So here's a company that you have manufacturing multiple products, all of which can be disrupted to a great extent by AI factories, embodied AI in humanoid bots.
Right. So one thing is, I would disagree with Jensen about brownfield and greenfield opportunities there. Yes, brownfield basically means that I have the factory, I have the processes, and I swap one for one with a human with a humanoid bot. That's what he's talking about in terms of brownfield. Greenfield is I make a factory from the ground up, and I put in systems and processes that relate to the new way of doing things and how I do that. My dispute with that is that if you think of Costco, they have their pallet, their forklifts, and everything about how they run the warehouse store is around forklifts giving 8 to 10 times the productivity versus stocking shelves and selling things the old way, right? To not have new processes, right? So if you have humanoid bots, you would want to make new processes that are centric to the human bot, that enable it to go faster and do more things. The advantage that Tesla has there is that they make 5,000 changes a week in their factories. So they have work zones, and then they have teams working on it, and they have multiple work zones, and something can go through not just down a factory line where it's like I do something here, pass the next line, pass the next line. It can go to multiple points. So I have the initial frame built, and then I go to 3 different zones where I'm installing the HVAC, and then everything's being monitored, and I can make adjustments where I'm digitally twinning the system and device, and then I can say, okay, car 1 versus car 2, the next car down the line is different from the previous one, versus the traditional companies where they must do a product line launch every year. They do a set of changes for the old system have a high cost versus a very low cost for Tesla, right? So that kind of rethinking the factory is an important thing for humanoid bot. Otherwise, yes, I save the salary of the worker. I'm able to come down, even with the expensive worker in Mexico or China, other places. I bring that cost down with the humanoid bot. It works more shifts. I go down to $10 an hour because of human bot. But if I redesign the processes, then I can get 4x, 5x the output out of the one factory footprint, or maybe 10 times as much, which
Right.
is something that the unbox process that Tesla's trying to do, where they
Yeah.
build giant Legos, is something that happens. So the if you're just doing a no-brainer replacement of a drop-in, I take a person out, I put a bot in, and I don't change the processes. I don't change how I'm doing things, right? That will not give you as much benefit as changing the processes and
For sure.
redesigning it. Yeah.
Yeah. Because you're taking optimization to a whole new level, right? As Elon often says, the best part is no part. The best process is no process, right? Simplification. So this is where rethinking the whole process is important, because it's not just the embodied AI and humanoid bots. Really, that's we're looking at when we're talking about fueling this manufacturing revolution. It's also digital twins of factories, simulated design and training. The entire ecosystem really that is being transformed, right? And here's Jensen again talking about digital twins and designing factories in simulation.
As we put these robots into the factories, remember,
I've sped up this soundbite because it's a bit long, so that's why you're hearing it this way.
remember, the factories are also robotic. Today's factories are so incredibly complex. This is Delta's manufacturing line, and they're getting it ready for a robotic future. It is already robotic and software defined, and now in the future there'll be robots working in it. In order for us to create robots and design robots that operate in as a fleet, as a team, working together in a factory that is also robotic, we have to give it Omniverse to learn how to work together. And that digital twin, you now have a digital twin of the robot, you have a digital twin of all of the equipment, you're gonna have digital twin of the factory. Those nested digital twins are gonna be part of what Omniverse is able to do. This is Delta's digital twin, this is WeWin's digital twin. Now, while you're looking at this, if you look at it too closely, you think that it's in fact photographs. These are all digital twins. They're all simulations. They just look beautiful. The image just looks beautiful, but they're all digital twins. This is Pegatron's digital twin. This is Foxconn's digital twin. This is Gigabyte's digital twin. This is Quanta's. This is Wistron's. TSMC is building a digital twin of their next fab. As we speak, there are $5 trillion of plants being planned around the world. Over the next 3 years, $5 trillion of new plants. Because the world is reshaping, because reindustrialization moving around the world, new plants are being built everywhere. This is an enormous opportunity for us to make sure that they build it well and cost effectively and on time. And so putting everything into a digital twin is really a great first step, and preparing it for a robotic future.
Yeah. I mean, it's tough to put it better than he did, right?
Right. So these other companies are getting into digital twins, but Tesla's been doing that for closing in on 10 years now.
Yeah.
So that's the advantage they have, and the fact that they can go to by creating their own technology, being vertically integrated on that, then they can be sure to design what they need. So people say that the Cybertruck was a failure. Only 40,000 sold per year, but Cybertruck launched 48-volt architecture and steer by wire, and then they'll have I think brake by wire shortly in one of the other systems. Those things are key for making things modular, where instead of having to lay out all the wire harnesses,
all the cables, all the wires,
all throughout the vehicle, then I can have it in a module, all the wiring in there, and then have it snapped together and have the 48 volt
pieces,
like Lego pieces, right? So, but the thing is, that took the years of work to make the 48-volt architecture happen, right? So if you don't sign up for the actual, and I must do these other things in order to fully unlock some complete redesign, then you don't have it. So then if the companies are dependent upon NVIDIA, as good as NVIDIA is, then they are not able to go layers deep into the stack to change what they need to change. They can only do the surface level.
But do they need to? Because when you look at, and as you rightly pointed out and cited so many examples of the Tesla success story, right? That's just, think about what that's done for Tesla as a company, right? Now, imagine what that will do with the help of NVIDIA for the manufacturing sector as a whole in America. When you have those same ideas, the same processes, the same approach being adopted with NVIDIA's help by all these other companies, one of which is Foxconn.
Right. So, we're going to see that will the 5x, can the unbox process be released, and can that transform that, and will when they applied to making Tesla bots, will that production level go far higher? If Tesla's then able to execute, then that won't, the big gains don't happen, right? But supposedly next year, yes, they will have cybercabs being made, and they could have significant amount of unboxed process in there. Supposedly, they've shown some cybercabs that have already been built on test lines using a level of unboxed process. So we'll see. These other things, yes, we need to transform the factory. We need to go to digital twins. We need to put in humanoid bots. So it's a question of it's like at the beginning of the Industrial Revolution, you have Henry Ford making the new factory production line processes. Other companies were doing other things. They were making cars, but they were doing it manual or doing some other things. They didn't fully adopt new processes.
Yeah.
So then, does if you have someone who can execute the other approach, mass production is 10 times more productive, then that one would win on economics and other things.
Right.
So we'll see. Is a better than current approach with what NVIDIA is proposing here, what Foxconn doing, or do you need to do entire redesigns far more from the ground up, and being able to execute upon that in a timely way? So,
but when the Trump administration talks about bringing manufacturing back to America, and I think I saw, I think it was at a Morgan Stanley report a couple of months back that had this really interesting map that from the end of at the end of the Second World War, I think manufacturing was almost 28 to 29% of American GDP. And from there, it's just steadily fallen to barely about 10% of American GDP. So if the Trump administration wants to get this renaissance of and revival of American manufacturing, right, and bring American companies back, wouldn't this be the perfect way to do it? Because then you don't need to repurpose old factories, because if you're designing them from scratch, you can optimize them to the maximum with digital twins, designing the factories, the floor, the tooling, deploying bots in simulation, sim to rail training. It's the entire spectrum, and that really is perhaps the technology behind the policy, would you say?
Yeah, so basically the vertical integration of the company, where you have your designers and planners working with the factory lines and getting more productivity out of it. Tesla has shown that can work, but can every company do what Tesla does in terms of that vertical integration?
Right.
And if you're not vertically integrated, if you're saying I have my design team here in the United States, in LA, and I'm sending the plans over to some factory in China or Mexico, other places, then you're not getting the tight connection and innovation that they're having. So fine, I saved 5-10% on my overall labor costs by doing that, but then my supply chains all over the world, like Ford and Toyota and everyone else, and then versus a tight, I can make the innovations happen here, I can change the factory here, and the teams are working together. I think that the world of the future of AI and robotics, you want to have faster changes. A counter argument to that would be that if you have humanoid bots and you can have teleoperation and you can have the people connected directly to it, then you could be in another place and not have as much penalty for not being right there. But that teleoperation
that has its own challenges. That has
its
its
own
own set
challenges.
of challenges.
Yeah, you need to have some kind of like a holodeck type thing where you're doing it,
Yeah.
and in order to make it fully work, because just having the headset type experience doesn't give you the full thing.
Yeah, because when it comes to precision manufacturing, just those extreme precision in terms of timing, in terms of movement that are required, might not, teleoperation might not be the optimal way to go for that, because there's always a lag, and there's always a difference in calibration between the operator's body and the bot's body, right? So there's
Right.
small little differences which are all have to be taken into account. But that's an important caveat that you're giving there, that vertical integration is going to be critical to this transformation in American manufacturing, because as you rightly say, if you're still outsourcing part of your manufacturing process, then it kind of defeats the purpose, right?
Right. And it's something where I think the costs, especially in a rapidly changing world with a lot of AI and robotics and that kind of thing, is um, everything should happen locally, one spot. Everything gets produced in one thing, and it's just pumping stuff out, right? It's kind of almost like those the nano factory type thing where I'm taking molecules and I'm just like everything that's produced. Why would I have a distributed team of 1,000 people working all over the world doing it when everything can happen all in one spot? So I think that the advantages of being all in one spot and vertically integrated and having control of your tech stack and material stack and supply chain as much as possible is something that is a better way to go.
Yeah, it's all about vertical integration when it comes to moving atoms and photons. But here's the geopolitical question to you, my final question to you, the geopolitics of it. When you talk about supply chains, when you talk about interdependencies between the US and China, for example, do you think that level of vertical integration is possible geopolitically?
I think it is. Some things have delay where it takes a lot of time to get the skills, get the factories, get things moved over. So it would be, a 10, 20-year journey to do that, like shipyards, other things. There's a lot of things that take quite a long time to build.
Right.
But if you're building things super fast with robotics and other things, the movement could be faster than most people think. And if you say, I want it to happen, and policy-wise, I'm going to favor that to happen, then you can, get the movement to occur and to make it happen. And then the geopolitics of like if China separates from, they've done some, disengagement already. And
I
the thing
think that
is,
was a great stress test. The Trump tariffs were a great stress test because
right.
it exposed America's vulnerabilities, and the rare earth supply chains was one of them.
Right. But in terms of geopolitics of it, it works because the U.S. consumer is still 40% of
Right.
spending for the world.
Exactly.
China is now at the level or passing Europe on consumer spending. So if I'm vertically integrating below in terms of manufacturing production, it's like how much of the consumer do I have, right? And if the per capita income of other places is still less, then the how much of the consumer market do I have? Like if the US is able to supercharge its economy and get 3 to 4 times the per capita income, and the other countries fall behind, then they could get to 60, 80% of the consumer market, right?
Yeah.
And so then they would have even more dominance. So the power in a vertically integrated world is how much of the consumer economy do I have? So then they need to increase the strength of their consumer economy. Like China currently, of their GDP, which is not that far off the United States, only 30% is consumer economy versus 60%, I think, for the United States. So they need to give the state money to their consumers so that they can increase their consumer economy, right? So that is the the macroeconomic thing of like, and then for Europe they have to get again higher per capita income, another thing, because again they're falling behind on that, and then getting more youth, getting more babies, all that kind of stuff, right? So the what's the use of the person in a robotic world? The person use of the person is to be the consumer and the investor, right? So that's where you need to increase that on the human side.
Yeah. And demographics are also such an important part of that, even in the age of abundance.
Right.
That's the promise of AI and robotics. But yeah, wow, this has been brilliant. Thank you so much, Brian.
Thank you.
It's always, I've said this before. I love to think of these because they are really more brainstorming sessions than anything.
Right.
Go wild. Thank you so much, Brian. Really appreciate your time.
Thank you.
Hope to see you soon.